Okay, so we did our research on food tracking and examination of higher learning in Alexia, Californica. I'm Madeline Ruzika. I'm a senior biology pre-med major.
I'm Ashley Gerber. I'm also a biology pre-med major and a senior.
I am Porchia, and I am a biology major here at Quincy. So our animal of focus for this research are Alexia californica. To give you a bit of background, they are a saltwater invertebrate found off the coast of California and in the Pacific Ocean. I'm not sure if you guys have heard of an Alexia before, but they are more commonly referred to as a sea hare or a sea slug.
So when examining Alexia, we decided to compare them to a dog. And as we can see here, a dog has a brain, spinal cord, and various nerves. And overall, they have a very complex nervous system, just like we do as humans. However, if we step over here, we can see the nervous system of an Alexia. And we see that they are made up of large ganglia, and that's really it. And they are a very simple nervous system. However, we do know that dogs are able to be classically conditioned, and that's through the research done by Ivan Pavlov in his famous experiment with presenting food and ringing a bell with dogs and where they ate. And then over time, the dogs learned to salivate to the sound of the bell alone. So similarly, we also know that Alexia are capable of being classically conditioned through previous research done by Dr. Hale and other experts. And we also know that dogs are capable of higher learning, and we know this because they can do various tasks such as obstacle courses, learning new tricks, and even responding to commands of humans. So the aim of our research was to tell whether Alexia californica are also capable of higher learning, and we did this through the use of our food tracking.
So essentially, we would place each Alexia californica on its own tray in the bottom left-hand corner, and we would place its food source, which is red algae, in the bottom right-hand corner. And we would give it 2 minutes and 30 seconds to reach the algae, and if it did reach the algae, this would be considered a pass. And if it didn't, then it would be considered a fail. And if it reached the algae, then we would give it 5 minutes in which it was able to eat. And we essentially had 3 different training groups. We had group 1, which was trained Sunday to Thursday, group 2, which was trained Sunday, Tuesday, and Thursday, and group 3, which was trained Wednesday. Therefore, we could tell if the frequency of training would increase the pass to fail ratio. And here in our graphs, you can see the different results we had. The blue indicates a fail, and the red indicates a pass. And this was study 1 and study 2. So the difference between study 1 and study 2 was study 1, we trained the Alexia to eat the algae on the tray before we started training. And then study 2, they were not conditioned that their food was on the tray, so they were just trained immediately. And study 1, once they reached the Alexia, once they reached the food, they were immediately placed back in the tank. So initially what we found in study 1 was that towards the beginning of this semester, there was an increase in the pass to fail ratio, and then towards the end, there was a decrease. So essentially, our hypothesis behind this was that it occurred because they learned that they were being fed in the tank regardless of task completion. So essentially, they outsmarted us in the fact that they figured that they were getting fed either way, so this is evidence of higher level learning. And then in study 2, feeding was restricted, so if they did not pass, they were not fed for the day. And this was based on our hypothesis from study 1, and our learning, as you can see, was more inconsistent than study 1 because they seemed to develop an aversion to food. And our hypothesis behind this was that because of the feeding restriction, they did learn to not make a connection between food and the task. So essentially, they did perform higher level learning in the fact that they learned that they did not need to eat as much in order to survive. So both are evidence of higher level learning in Alexia.
While we did receive promising results from our experiment, there is still a lot of research that needs to be done. The preliminary data that we collected does show that Alexia californica have a higher learning ability, but the inconsistent results received across both study 1 and study 2 does indicate that we do need to find more research in finding a better training model for the Alexia. We need one that they will thrive in, one that suits them best. So while we were doing our research, we did notice that Specifically in study 1, when we were placing the aplasia right after training back into their tank with their food, they were tracking down the food and eating immediately. So this kind of rose the question, do aplasia have a better ability to track food, and do they have a better sense of smell in the water rather than out of the water, as water is their natural habitat? So this is a study that could be done in the future to see if we would receive more consistent results in the water rather than out of water, performing a similar training model. And once we do receive once we do get a better training model for the aplasia, we can go into doing new experiments. We could specifically focus on the one that our other research group did. They played various types of music for aplasia to see if they had any type of response, whether that be positive or negative. So we could take that even further and see if different types of music will actually affect the training and the learning ability of aplasia. Again, we cannot do that until we have a better training model that we get those consistent results from. Another thing we noticed while we were doing our research was that the age of the aplasia might have played a factor. In study 1, we used older aplasia that were much larger, and in study 2, they were younger and smaller, and we received more consistent results in study 1 using those older aplasia. So now we might think that we do need older aplasia to receive those consistent results that we want to see out of the training. Again, this data is preliminary, so we do need to research further to get better results, but we did receive enough results that show us that Aplasia californica do have a higher learning ability. We would like to thank the University of Miami for giving us the aplasia. That's where they were sent from. Quincy University facilities, because without these facilities, we could not have developed this research as far as we got. And also the other members of our group who focused in on playing various types of music for the aplasia. They helped us care for the aplasia and also train them throughout the course of 2 semesters. So we are grateful for that. Again, we received great results from this experiment. It was definitely a learning experience, but the more that we research Aplasia californica and other organisms and their higher learning abilities, the more we can learn about us as humans.
And then here's just an aplasia.